Hello everyone, I'm Pavithra, third year ECE department from Sri Venkateshwara College of Engineering, Tirupati. Me and my friend Anita were here to present the embedded system internship. The language which we learned in this internship is C programming language. First of all, C was developed by Dennis Richard in 1972. And it is a general purpose language even though it is applied and used effectively in various specific domains. It is a free formatted language. It is efficiency and portability language. Library facilities plays an important role. It is an platform dependent language. Applications of C means where we use C programming language. We use C programming language widely in embedded software development, system software development, file system development, operating system kernel development, and many more applications C is used. Syntax of C programming language. Mainly, it contains the five sections. Documentation section. In this section, it consists of set of commenting lines. Means those are not executed by the programming. It was used for understanding purpose. Procedure statements. These are the statements which were start with the symbol hash. Mainly we see it in many of the programs that hash include etc. Global declaration. Global declaration means here the global variables and function declarations are present, and the variables which we used in this can use anywhere of the function. The main code it consists of local declaration, program statement, and function calls. One or many functions. It contains the function body, data types, and modifiers. See, data types consist of two two types of data types, primary data type and secondary data type. Primary data type consisting character, integer, float, double, void, and secondary data type consisting of arrays, pointer, structure, union, enum, etc. And modifiers. Modify consisting of short, long, signed, unsigned. Here character it consists of it requires 1 byte of data, where integer requires 4 bytes of data, float requires 4 bytes of data, for real numbers double it requires 8 bytes of data. For 16-bit systems, int short int requires 2 bytes of data, for 32 byte 64 bits integer requires 8 bytes of data. Signed. Signed it requires the both positive and negative, where unsigned it allows only positive. Conditional constructions. Conditional constructions are it consisting of two types, single iteration and multiple iteration. In single iteration, it consisting the if and its family and switch case. For multi iteration, it consisting for while do while. In single iteration, if else and switch is present. In if else, it is divided into four types: if else, if nested if. If the statement or the condition is true, then it executes the if block. In if else, if the condition is true, it executes the if block, otherwise, it goes to the else block. Similarly, it is applicable to the if else and nested if, in which case multiple cases were verified. Embedded system. Embedded system is a combination of hardware and software designed to perform a specific task. Different categories of embedded system. Household it fridges, fans, micro oven, washing machine, etc. In wearables, smartwatches, fitness devices, medical equipments, diagnosis lab tools, robotic surgical equipments, ECG, etc. Embedded system were mainly used in washing machine. Washing machine. It is the project what we are doing in this internship. In washing machine is an electronic device that is designed to wash clothes and lines automatically. Here to control the washing machine, we are using the embedded system. Here there are different modes to control the washing machine. Those are nothing but load select knob, water intel select knob, mode select knob, program select knob. Components of embedded system. These are the components which we require to perform an embedded system. Those are software, memory, data to address conversion, address to data conversion, sensors, user interface, diagnostic port, electronical backup and safety, external environment, actuators. Requirements. To start this internship, we require these are the requirements which we requires are reliability, cost effectiveness, low power consumption, efficient usage of power, processing power, efficient usage of memory. Problem statement. This is nothing but to develop a washing machine, we require some of the interfaces and stimulate it which displays and allow user to select different types and allow user to select different types of washing modes on pressing digital keypads and water levels on long press. It means we select which type of cloths are we using and what amount of the water level we require to wash that clothes and how the machine is starting, how we control the washing machine. All things were be used in this problem statement. The software which we used in this internship is MPLAB XIDE, where the code is typed XC8 compiler. Here the program get compilations will be start from here, and this PixMLab. PixMLab here we see the output of the input. Architecture of the board. Here we use the IC is PIC 167F877A. It consisting of the RS232 LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, ADC, LM35 temp sensor, dual C, PIC 16F877A, GPIO, LED. LED is nothing but light emitting diode. Is a semiconductor light source that emits light when current flows through it. White light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconductor device. Simplest device used in most of the applications as feedback. Some applications are home lighting, remote controls, character liquid crystal display, CLCD. It is nothing but it consisting of the alphabets and the numbers. It consisting of 4 rows and each row can print 16 characters. It works on both 8-bit and 4-bit mode. It has 8 data transfer lines. Those are starts from D7 and ends with D0 to D7. RS for instruction register and one for data register. Enable pin and read write pin. Tactile switches. These are the switches which performs the both two operations. Those are level triggering and edge triggering. It is a momentary push button switch, 4 legs and corresponding 4 terminals. 2 terminals are shorted, one on one side and one side on other. When pressed, all 4 terminals are shorted. An array of tactile switches from the digital keypads were displayed here. ISR, fan, buzzer. These are the some of the requirements used in this Bixum lab. Those are interrupt service routine. It tells the processor to control what to do when interrupt occurs. Next, fan. Fan is a cooling type. It is used for cooling the system or onboard and passive cooling fans are now mostly used in all desktop computing and embedded system. Buzzer. Buzzer is an embedded system widely used to notify the weather system is on or not. A buzzer or beeper is an audio signaling device which may be mechanical, electromechanical, or these typical uses of buzzers and beepers includes alarm devices, timers, train, and confirmation of user input such as a mouse click or keystroke. Let's see the demo of the project. This was explained by my friend Anita.
So let's see the project demo. So we already learned about the requirements used for the washing machine. So recall what are the components used for the washing machine program. This is the welcome screen of the washing machine program. So this is the CLCD screen. Here we display the press key 5 to power on the washing machine. Here there are so many LEDs and there are four ports, port A, port B, port C, port D. These ports has different types of directional control registers. Port A has TRIS A, port B has TRIS B, and port C has TRIS D, TRIS C, and port D has TRIS D. And we have buzzer to perform the specific function, and we have fan in this washing machine. Here we have six switches. These are RB0, RB1, RB2, RB3, RB4, RB5. To implement these functions, we can code. So let's see the code for washing machine program. This code can be write in the MP lab. So we can see this is our washing machine file. So in washing machine file, there are header files, important files, linker files, source files, libraries, and loadables. In header files, we have CLCD, digital keypad, main, and timers. And source files has CLCD, digital keypad, ISR. ISR means interrupt service routine, and main timers. We implement the code in these header files and source files. Mm. So we select these files like this. So go to header files. Next click on the new. We select option other. Next there are so many options. We select the C. Next here is the C source file. We select and click on the next button. So we put the file name. Next finish. In this like we did all these files. Next go to the main source file. This is our main source file code. This is our main header file. This is the functional block for initialization of the CLCD, digital keypad, and different types of operations. And there are different types of washing programs like daily, heavy, delicates, whites, stain wash, eco cottons, woolens. If we press the switch 5, these all washing programs are displayed on the CLCD screen. Here we have water level option like auto, low, medium, high, maximum. These are all displayed on the CLCD when we implement the code in Pixim Lab. This is some necessary things, and this is the void main program. Here we have press key 5 to power on the washing machine. If we press the switch 5, this is displayed on the CLCD. Next we have clear screen option to clear the screen. This is some code. Here we have power on screen to power on the screen. We print the power on the washing machine. When we press the switch 4, we display like power on the washing machine. This is the code for washing program display. These are all some necessaries which we implement in the code. This is the program for the water level display. This is code for set time. Set times means timer is set. If we perform any operation, the timer is going decreased. This is all this code. Next, here is the program for the run option. This is all this program. Next, here is a void door status check. For door open, RB not equal to 0. When we press the switch 1, the door will be open. And for the start option, we press the switch 5, and pass option, we press the switch 6. This is our main source file. This is the CLCD header file. We can implement so many functions in this code. This is the digital keypad header file. This is main header file. This is timers header file. This is CLCD source file. This is digital keypad source file. This is ISR source file. This is timer source file. Now we are going to see the simulation in PiximLab. This is the PiximLab. Here we use PIC16F877A. Before we are load hex file, we should select the board as PicGenius, and we should select microcontroller as PIC16F8. Put the frequency 20 megahertz, and here is 16 cross 4 and 16 cross 2. So now we use 16 cross 4 LCD to display the 4 lines of the code. If we select the 16 cross 2, we can display only 2 lines of code. So we are going to load hex file. Go to file and load hex file. Now we can select our file, open. Next, press switch 4. Display the power on the washing machine and washing machine programs. There are different types of washing machine programs like daily, heavy, delicates, etc. So these programs can be navigated by pressing the switch 4. If we press the switch 4, the programs change like this. We can see. So we can select one program by long press. We select heavy. Next, this is the water level screen. Here we have auto, low, medium, different water levels. So we can select one. We can select low. Here we have press switch 5. For start the operation, we press the switch 5, and stop, we press the switch 6. So I press switch 5. Here we have function wash, and timer is running and fan is running. If the program can be passed by pressing the switch 6, now I am pressing the switch 6. The program is passed. Timer is stop and fan is stop. So our program can be start by pressing the switch 5. So we can see timer is running and fan is running. The function is wash. Next, if the door can be opened by pressing the switch 1. Let's see. We heard buzzer sound. Next, the function performed is strings. The timer is going decreasing. LEDs are blink. Now function is spin. The program completed. That time the buzzer is here. So this is all about what we have implemented in this internship. So thank you, MSc Information Technology. Thank you all.